Today we're looking at Unit 7, Day 5, Rhombus and Squares, or rhombis and squares. Okay, a rhombus is a parallelogram with all sides congruent. So because it's a parallelogram, it has all the properties of a parallelogram. For example, I know my opposite sides will be parallel and congruent. So this side will be congruent to this side, and then this side will also be congruent, and I don't have to put separate tick marks because I also know that all sides are congruent. My opposite angles are congruent, so this piece here is the same measure as this one here, and then these opposite angles are also the same measure as each other. Consecutive angles are supplementary, so angles on the same side add up to 180. So for example, if I have an 80-degree angle here, the one right next to it would be 100, and the one next to that would be 80, and the one next to that would be 100, because the one next to that is 80, and you could keep going around and around and around. And then the last one for parallelogram is that my diagonals bisect each other. So this diagonal and this diagonal, when I cross them, they bisect each other into two pairs of congruent segments. Notice I put different tick marks because these two do not have to be the same length as these two. Okay? Now, properties that are unique to just the rhombus. It doesn't happen to other shapes, to other parallelograms. It just happens to the rhombus. Okay? The first one is that the definition of the rhombus says all my sides are the same length. So all of these, however long one is, the other three are the same length. The second one, diagonals are, and then if you don't remember what this upside down T is, you need to write it somewhere and like put it up on the wall in your room so you don't forget it, because it's a really common symbol that we've used all year long, perpendicular. And if you don't remember what that means, you really need to put it up on the wall so you see it every day. That means 90 degrees. So when I draw in those two diagonals, they are going to intersect each other at a 90-degree angle. And that doesn't happen in your regular rectangle or your regular polygon. It only happens in your rhombus. Okay? And then number 3, the diagonals bisect the vertex angles. This is the first time we've talked about the vertex angles being bisected. Remember, your vertex, your vertices, are the four corners, right? So when I draw in this diagonal, it's going to make this angle congruent here. And since my opposite angles are congruent, right, my opposite angles are the same, when I bisect the other end, it's also going to make the same two angles. Okay, so for example, when I draw this diagonal in, I'm going to have 40 and 40 and 40 and 40. Okay, that's true for both diagonals. So this is also going to divide not into these same four angles, it's going to be a different set of four angles. Okay, so up here when I draw in this diagonal, I'm going to end up with 50 and 50, 50 and 50, 40 and 40, 40 and 40. Okay, so those are our 3 unique properties that belong to every rhombus. So now what we're going to do is we have been given this rhombus, okay, and we have just a little bit of information. All we know is this angle is 53. We know this piece of this diagonal is 3, and we know we have a side there that is 5. Okay, so we can take each little piece of our rhombus properties and fill in what we can fill in from what we know here, and then we can use anything that we still haven't figured out. We can use properties of our parallelogram. So number 1, all my sides are congruent. So since I know one side is 5, that means all of them are going to be 5. So A is going to be 5, B is going to be 5, and C is going to be 5. So I can fill those in. 5 and 5 and 5. Okay? Then the next thing, if I go on and I look, it says my diagonals are perpendicular. That's my second unique property to the rhombus. So my diagonals are going to intersect at a 90-degree angle. So that means I know what E is, and I also know what G is, because all 4 of these angles in here are going to be 90 degrees. So E is 90 degrees. I didn't get D, but don't worry, we'll get back there. And G is 90 degrees. Okay. All right, so now let's move on to my third property unique to a rhombus, and that's that my diagonals bisect the vertex angles. So that tells me that if this angle here is 53, this angle here is also 53 degrees. So J is 53 degrees. And then remember, we talked about how because my opposite angles are the same, that those opposite corners will have the same two angles. So when I move to the opposite corner, these angles are also both going to be 53. 53 degrees. Okay, so M is 53 degrees and K is 53 degrees. Okay, so that's the information we have because it's a rhombus, and I used a little bit of the properties of the regular parallelogram using that my opposite sides, or my opposite angles here, my 53 and 53, my 53 and 53, okay? So now we're going to have to use our parallelogram properties to find everything else out. So the first one, when I come here, my diagonals bisect each other. So if I know one part of the diagonal, I know the rest of that diagonal, okay? So if I know that this piece here is 3, I know this piece here is also 3. So now we have found D is 3. Okay, D is 3. All right, then, as I'm just working backwards, my consecutive angles are supplementary. So angles on the same side have to add up to 180 degrees. So that means this whole angle on this side, which is 53 and 53, so it's 106. And then I could use either this left side or I could use this right side. If I go with this bottom side down here, these two angles together I know are supplementary. So if I've used 106 degrees here, I need to know what's left for down here. So if I do 180 minus 106, I end up with a 74. So that's the whole angle there, right? But I know that it's being divided into two individual pieces. So if it's being divided into two equal pieces, 74 divided into 2 is 37 degrees. So R is 37 and S is 37. That also means up here N and P are both 37 because opposite angles are congruent. 37 degrees and 37 degrees. So now the only things I'm missing are F and H. Okay? When I look at F and H, F is here and H is the other half of that diagonal. I know they're equal to each other, but I need to know what they are. And I've kind of exhausted all my properties of diagonals anyways. So I'm going to have to even think back further in what we've learned. And I'm going to look at this triangle right here, because this triangle is a right triangle and we spent 3 units, 5, 6A, and 6B were all on right triangles. Okay, so this side here is 3, this side here is 5, and I'm trying to find what is F. Well, F is a leg, and I know if I'm trying to find a leg inside my square root, I'm going to subtract my other two, the bigger one, the smaller one, 5 squared minus 3 squared, and that's going to give me, when I put that in my calculator, an answer of 4. If F is 4, then H is also 4. So F is 4 and H is 4, and we have now found every segment and every angle when all we started with was half a diagonal, one angle, and one side of this rhombus. And we were able to find everything else. Okay? In the next video, we're going to look at what makes a square unique. All right, thanks for watching.